Hey guys, welcome to the next video assigning R and S configurations to our molecules. So this is going to be a continuation of the previous video. So if you guys watched the previous video, we talked about two of the three scenarios we have for R and S configuration, right? Our easiest one was when our number 4 priority, our lowest priority group, is dashed. Our second scenario was when our number 4 was wedged. Right? And now we're going to do the third scenario where the lowest priority group is in the plane. So planar, right, has the solid line. Okay? And so before we do this, all right, I want to introduce a trick that is useful for you guys to know, which will help us in the third example, in the third situation, okay? And it's called the swap method. All right, and so I'm going to draw this molecule here. Okay, so we have this molecule. And so what's the first thing we should do is let's determine if it's chiral or not, right? So the carbon has a chlorine, a bromine, a hydrogen, and a methyl coming out of it. These are 4 unique substituents. It's tetrahedral, and it's sp3 hybridized. So we know it's chiral. All right, and now let's assign RNS configuration. If you guys want to try this on yourself first, feel free to pause the video. Okay, and so let's get started. This would be the first priority group, second, third, fourth. All right, our lowest priority group is dashed, so we don't need to worry about anything else. This is our easiest scenario. So what I'm going to do is just cross the 4 out and draw an arc from going from 1 to 2 to 3. Okay, that's counterclockwise. And so this configuration is going to be S. Okay, so we have an S configuration. So now what I'm going to do, let's keep our numbering here. So now what I'm going to do is I'm going to swap 2 of the groups. Okay, so what I'm going to do is I'm going to swap the methyl for the bromine. So I'm going to put our methyl here, and the bromine here. And so let's redraw that. Draw what you know hasn't changed. So we swapped our methyl for our bromine. And let's just renumber our priority, right? Okay. So our lowest priority group is still dashed, right? And so it's still dashed, so we don't have to worry about any weird things here. This is our easiest way of not, assigning RNS. And so let's cross out 4 and draw the arc from 1 to 2 to 3. Okay? And so this is clockwise now. So this configuration is now R. Okay? So I want you guys to see what I just did. I swapped 2 groups, right? I did 1 swap. So let's keep track of our swaps here. So I did 1 swap, and the stereochemistry at that chiral carbon flipped. So we went from S to R. So what does this really mean? Well, how does this really help us, right? Well, what I want to do is I want to do 1 more swap. And after that, we'll be able to do R and S, okay? So I'm going to perform 1 more swap. And so let's swap now 1 and 2. Okay, so the bromine with the chlorine, putting the chlorine here. And I'm going to put the bromine there. So the chlorine goes here now, the bromine goes here. And now let's do our priority again. 1, 2, sorry, should have been 2, 3, 4. Cross out the 4, and the lowest priority group, number 4, is dashed. And so we can just draw a normal arc. And that was the wrong direction. 1 to 2 to 3. And now it's counterclockwise, so now it's S. And we performed 2 total swaps. So let's analyze what happened here. We started with an S configuration. We did one swap, and it flipped the stereochemistry at that compound, at that carbon. So if you know your definitions like enantiomer and diastereomer, which I haven't gone through in these videos, right? In this case, because we only have one chiral carbon in our molecule and we flipped it, it's going to be R. I mean, we just created an enantiomer. If we had other chiral carbons here and we only flipped one, then it is called a diastereomer, okay? Because only one of them changed. But here there is only one chiral center and we changed only that one, and so it is an enantiomer. All right, but I'm not going to focus too hard on those definitions right now, at least. All right, and so I did one swap and we turned an S configuration to the R configuration. I did another swap and we got our original structure back. Okay, and so how does this method help us now? All right, and so this brings us to our third situation for when assigning RNS, when your lowest priority group is going to be planar. Okay, so we have this carbon, CH3, H, chlorine, bromine. Let me just change that up. Bromine, right? And so let's assign our priority. 1, 2, 3, 4. Okay, so now if you remember, our first situation is when, our easiest situation is when the lowest priority group is dashed. We can just cross it out, draw an arc, and there we go, we're done. When our lowest priority group is wedged, right, we draw our arc, and whatever configuration it looks like, so if our arc looks counterclockwise and we get S, it's really going to be R. Okay, that in this situation, none of those tricks work. All right, so none of those tricks work. So what we have to do is we have to use the swap method. Okay, and so what you want to do is do 2 total swaps, because remember, 2 swaps get our original structure back. So if one swap gives us our diastereomer if we have more than one chiral center, or enantiomer if we're only dealing with one chiral center, so one gives us the enantiomer and diastereomer. A second swap gives us our original, right? If I added a third swap, again, we'd get an enantiomer or a diastereomer. A fourth swap back to the original, and so on and so forth. Okay, so you need to do 2 total swaps just so you can get back to your original structure. All right, so the first swap always has to be to get the lowest priority group in the dashed position. So I'm going to cross out our 4 and our 1, and I'm going to exchange them. So 4 will go here, and our 1 goes there. And so let's redraw it after one swap. So the dashed group is now the hydrogen. Our chlorine and our methyl stay the same. And this planar group is now the bromine. So that is one swap. Okay, but this gives us a diastereomer, or in this case an enantiomer, because we only have one chiral carbon. So we need to do a second swap. So let's renumber 1, 2, 3, 4. And so we need to do a second swap. It does not matter which groups you swap as long as you do not swap out the lowest priority group anymore. You have it dashed. It's exactly how you want it. So we can swap 1 and 3, 1 and 2, or 2 and 3. Doesn't matter which ones. So I'm just going to arbitrarily pick one, and let's swap 1 with 3. So put the 1 there, put the 3 there. Okay? So let's redraw now. Carbon, the H was here, we didn't touch it. The chlorine also wasn't touched. Now we have our methyl there, and our bromine goes there. So now let's renumber our priority groups. 1, 2, 3, 4. Now our lowest priority group is dashed, so remember, we can cross that out, and now we can draw our arc. 1 to 2 to 3, clockwise, so it's going to be R. Okay? So remember, we need to do two swaps. One swap, the first swap should be to get our lowest priority group dashed, and the second swap is simply to get our original molecule back. So swap any other groups but the lowest priority group one. Okay? And once the lowest priority group is dashed, we can treat it again like our easiest scenario, where we draw an arc. If it's counterclockwise, it's S. If it's clockwise, it's R. All right. Now, if you don't want to keep redrawing the molecules, we can go at it like this, and this is how I like to do it. Just because redrawing constantly wastes time. So they gave you this, right? Our original molecule. Number up your groups, right? 1, 2, 3, 4. And we know we have to do two total swaps. And so what I'm going to do is I'm going to just keep swapping the numbers, but without redrawing anything. All right, and I'll do it in a different color so you guys can see. I'm going to swap I'm going to do the first swap to get our lowest priority group dashed, right? So it's going to be 4, and then it's going to be 1, correct? And now that's one swap, and now I'm going to swap any two other groups. And so I'm just going to swap in a different color, 2 and 3, put 2 up there, put 3 here, and so we have two total swaps. Cross out our lowest priority one, and draw your arc. 1, 2, 3. Clockwise, which equals R. Okay? And there we have it. That is our third scenario for determining R and S configuration. I hope this video helped you guys. If it didn't, please feel free to email me, go to the CLC and to the TAs or Professor Office Hours. If you're watching this on YouTube, please feel free to comment below so that other people who may have the same question as you, they may have the exact same question, and if I answer there, others can see it. All right? And so I will see you guys in the next video on more stereochemistry.